All right, I'm Jeff Nimmo. Some of you have seen me earlier. Thanks for coming back. Water levels are pretty important to what we do. I'm probably not going to cover anything that you don't already know, but hopefully there might be something in technique or device or general knowledge that I can impart on you that makes your time worthwhile. So hopefully that's where we end up. Who does groundwater modeling here? Anybody? Okay, how important are water level meters or water level measurements?
Pretty necessary at about every plant we go to.
Right. So it's interesting that something so simple has a fundamental impact on what this industry relies on for making good decisions and using data to understand how properties may go into a property transport or remediation or some type of other mitigation. Monitoring wells are generally monitored from the same point on the well each subsequent time that they're monitored. Generally, the north side of the well has a notch or a mark. It's surveyed in. The coordinates X, Y, and Z are used to help identify the groundwater gradient. So a good water level tape is something that gives a good accuracy down to 1/100th of a foot or in millimeters is used. Sometimes the gradient of the subsurface water is very gentle sloped and sometimes not sloped at all. And sometimes we find anomalies, things like broken storm drains or sewers where water tends to funnel. And doing good water level measurements will help you identify some problems that you may not see from the surface. Typical tools, pretty simple, standard water level measuring tape. We also have sonic now has become more and more popular. Sonic devices are very accurate, but there is some fine tuning necessary to get the accuracy up with a standard water level meter tape. Ours in particular uses a steel surveying tape that's coated in polyethylene. So the accuracy is repeatable, and our standard is 1/100th of a foot per 100 feet. So pretty accurate standard. The thing that sets apart the Geotech water level meter from a lot of others that may be on the market is the measuring point is at the tip of the probe. When trying to gather good water level measurement data, displacement could be an issue. There's some probes that the conductivity device is in the center of the probe, which doesn't seem like there would be much displacement, but the narrower the well, the greater the displacement potential. So having the measuring point at the tip of the probe is pretty important in terms of accuracy. The tapes, again, metric and engineering scale. The Geotech water level meters are a little different than a lot of others. Again, one of the things we try to do as a company is take feedback from people that actually use the equipment in the field. Some equipment uses plastic tapes or plastic cords. They tend to stretch, they tend to warp. Sometimes the measurement increments are worn off. The tapes that we use are a poly-coated steel tape. The numbers are protected from any abrasion. The frames on our 300 foot and shorter tapes are a solid core aluminum instead of a painted metal tube. So they're non-sparking, they don't chip, they don't rust. The spools are machined from a solid block of polyethylene. They're not put together with screws of separate pieces. So in colder climates, they're not subject to breakage. We do have water level meter tapes that go up to 3,000 feet with the same tape. So that level of accuracy, 1/100th of a foot per 100 feet accurate, provides for accuracy at deeper wells. The different tapes are kind of illustrated here. One of the things that is becoming more important in our industry is the PFAS question. can I use this as a PFAS-free device? We've manufactured our water level meters, particularly the 3/8" probe. It's Delrin and poly. It doesn't have the materials that are of concern for PFAS monitoring. Something to keep in mind. We also changed our 5/8" probe. We used to have a Teflon insert for durability and inert. We've also changed that to a Delrin, so now that 5/8" probe is available as a PFAS-free as well. The plastic tapes, the MDPE, the key difference and where the accuracy comes into play is the steel tape is literally a 3/16 wide steel tape with stainless steel conductors on either side of it, whereas MDPE stands for medium density polyethylene. It's literally a plastic tape with 2 conductors on either side. So it's subject to stretching and warping. It's a little lighter, so as a trade-off, you still have that accuracy, but they tend to fade with time. Steel tapes are heavy, and if you're using a water level meter that's 300 feet in length or less, it's pretty easy to manage. You get upwards of 500 feet plus, and now you're talking about a 40-pound device, especially when you get into the 1,000-foot range. I think it's 38 pounds. So unless you have a strong platform to rest the tape on, like a tailgate or a work surface, you can get pretty tired pretty easily. The Scientific well sounder is a sonic device. It uses sound waves that bounce off the surface of the water to reflect back to the receiver and give you a water level measure. These are very accurate if they're tuned properly. They're not as accurate as a water level meter tape. So depending on project requirements, you may be okay with the sonic device, especially if it's a deeper well and you're looking for generalized data versus a site that may have something that's a little more intense. We find that sites where the water table is greater than 500 feet, the sonics can be pretty advantageous. The sound waves are resolution of 0.05, so 5/100ths of a foot. The steel is 1/100th of a foot. So making a decision on what's the best tool for the job, that degree of accuracy is going to be pretty important. The range is from 9 feet to 7,000. I mentioned our water level meter limitation for a tape is 3,000 feet. I think that's pretty standard industry-wide. So if you have something that's greater than 3,000 feet, and there aren't a lot of places that that's an issue, but some places in Nevada, I know that the water table doesn't start until about 2,500 feet. It's a big, deep hole in the ground before you find water. The thing about the sonic that's important to understand is that temperature, and if there's any obstructions in the well, like pumping systems or other things, they can be accounted for in gathering the data, but they're not going to be necessarily as accurate as the tape. If you have a monitoring well where there's no equipment in it, it's probably going to be just fine, provided that degree of accuracy is acceptable. But if you're looking for good groundwater modeling data, the tape is probably the better way to go. There is a place for both technologies. They're both portable, they're both very reliable. Again, it becomes a question of the quality of data and the managing of the equipment in the field. Most of the wells, I think, generally are within the 200-foot spectrum for most people, but there's some outliers that get into the 500 to 1,000-foot range. Again, there's not a lot to cover in this particular subject matter, but I think the key thing is if we're establishing a monitoring point and you're using that monitoring point on all measurements at the site for the history of the site, the things that may change the elevation of that measuring point is if you install a pump with a well cap that changes the elevation of that measuring point. So, I see you looking at me a little.
Yeah.
So on a normal casing, you pop open the well, you have your measuring point, and it's marked on the well itself. But let's say you install a dedicated pump system. You're not going to pull the pump system to take the water level measurement. But by adding a well cap, you're adding vertical height to the wellhead that has to be accounted for in your measuring point calculations. So if it changes the elevation of that measuring point by 4/100ths of a foot, you'll have to account for that change in that measuring point if something is installed in that well that changes that elevation. It's not a lot, but as we were talking about earlier, it could mean the difference in a change in gradient. I had a project site in Wyoming. I mentioned the broken sewer line. This remediation system we were doing. We're doing site monitoring, and the groundwater gradient trended east, except for on the west side of the site, the water went precipitously west, and there wasn't any geologic feature that would indicate a change of why that elevation would split mid-site. And we found that there was a storm sewer that ran under the street adjacent, and that storm sewer had a breach, and the groundwater was flowing into that storm sewer and creating a low point on the site. So that's something that you can discover with water level data. Another site I had in Pasadena, California, was very anomalous. One side of the site, the depth of water was 35 feet, and exactly halfway across the other side of the site, the water table was 60 to 65 feet. I can't remember the exact number. We looked at the geologic data, and there was a fault bisecting the site. We looked at the drilling logs, and we saw the disparity, and that accounted for the change in water table. It was a remediation site, so we had to make some decisions on what that meant in terms of product migration off the site. So just some interesting things that you'll find. What's the best tool for the job? Depends on the site, how much money you have for the project, and whether or not it makes sense to rent or purchase. So again, not a lot to cover, but I want to make sure we touch on a few things. Does anybody have any questions?
I have a question. For the sonic measuring instrument, is well kind of material construction or straightness an issue?
Straightness can be an issue because you're dealing with sound waves. The device is adjustable to account for obstructions or bends in the well, as well as factoring in temperature, which has an effect on the accuracy of the sounder getting the signal. So in a word, yes.
And then construction of bare PVC versus steel versus degraded steel, can it compensate for that?
It's not an issue from my understanding. Temperature is more variable than materials of construction. But I think anytime that you're going from a steel tape or any other type of measuring tape to a sonic unit, it's always good to compare before you transition. If you go in with just the sonic, you're probably going to have a higher degree of error than if you compare it with a standard tape. So that would be my only advice. Anybody else? Yes?
Just to build off that, would having a dedicated pump installed affect the sonic reader?
It can be compensated for.
Okay.
Well diameter, I think the level of accuracy just from a practicality standpoint, if the pump is submerged and the only thing coming out of the water table is the tubing and or motor lead, you can still adjust it to compensate for whatever the obstructions may be. If you have a sounding tube in the well, I think you're better off, all things being equal, than if you don't.
Okay.
Yeah. Yes?
So what if the water table is below the top of the screen? Will that mess up the sonic?
No, because you're reflecting off the surface of the water. Good question. Anybody else? Yes?
With like the metal tapes, do you recommend like, can they be like stored just in a truck, or should you bring them inside, like extreme weather or anything, or
So,
they like expand and get out of?
so the steel tapes are a hardened steel. So they, like any material, you're going to have some variability with temperature. Probably not as much as you're thinking there might be. The tape itself is encapsulated in polyethylene, has stainless steel conductors. Storage, can you keep it outside? We have a canvas bag that you can get for them. They're a double wall canvas bag. If you have a toolbox or something where it's not going to roll around and compromise the tape. The biggest killer of any water level meter is a compromised tape. We recommend putting tape guides or something that's going to protect the tape as it goes over the edge of the well. The heavier the water level meter, the more of a chore that becomes because it's just so heavy to manage, and you're trying to manage the descent of the probe and then trying to reel it up. If you have a 12-pound water level meter versus a 40-pound water level meter, just the ergonomics of that alone make for some challenges. But if the tape gets scraped and gets wet and it starts to corrode or freeze, in this case, it could create a bigger problem. So if water does get in the tape, that might be an issue more than expansion and contraction of the material. Okay. Yes, sir.
Yeah, can the sonic probe detect product within a well or just liquid?
It's liquid. Yeah, so the key difference, and we didn't go into any of the interface products today, interface products rely on fluid conductivity to differentiate between product and water. So with an interface probe, product is non-conductive. So some other mechanism in the probe itself is telling you there's a fluid because it's either breaking a plane of light on a prism, or there might be a float mechanism with a float switch. But nonetheless, the conductivity of the water is the key thing in a standard water level meter. So if you go to a sonic, it's going to bounce off whatever that surface is. If there's a 100th of a foot of product or 10 feet, it's going to give you that top layer. Anybody else? Pretty basic stuff. I'd like to make it more juicy and exciting, but it's throwing a tape down the hole and having some fun with it, right? Decon's important, tape care is important. Water level meters such as ours have a sensitivity knob, right? One of the things that happens in monitoring wells, depending on where the screen interval is you might get some cascading, right? You have water filtering in through the screen and running down the casing. That may falsely trigger the water level meter to sound, giving you an indication that the water table is at a different elevation than it actually is. If you suspect that that might be an issue, you can use the sensitivity adjustment to tune that out until you get into the water itself. That's a pretty important thing to know, right? Condensation is another potential problem, giving you a false reading. There's a lot of humidity in the inside surface of the well. As that probe goes down, it may gather some of that fluid and give you a false signal, an intermittent signal. Right? The water levels we make, the sensitivity is 10 micromoles per centimeter squared for conductivity, which is pretty low. I mean, that's like glacial water in terms of sensitivity. So that adjustment on sensitivity can be pretty important, depending on the well conditions. Okay. Cool. Decon, to your point, if you're going to store it, drive around with it. I always advise if you're going to use it in a well and treat every well with the expectation there might be a cross-contamination issue. Decon the probe, don't put any more tape in the well than is absolutely necessary. It's just time saver, it's a little good housekeeping thing. The question of sounding the depth of a well with a water level meter, does anybody think that's a really good idea? I'm asking it a little bit rhetorically because it's really not. You can, a lot of people do, but it's a water level meter, it's not a tag line. And from a maintenance and wear and tear circumstance, if you're sending a water level or interface probe to the bottom of a well, there's frictional elements, there's impact elements, and over time, you're going to get additional wear to the probe itself, and maybe even compromise some of the connections by bouncing it off the bottom of the well. So water level meters aren't designed to be tag lines, although they're used for that. There are tag lines available which are good for that because there's no moving parts or electrical components. So pretty important difference. I think as a manufacturer, when we get equipment in for repair or service, that's probably the number one thing we see is like the bottom of the probe. Our probe tip is at the very bottom, gets impacted and scratched up, and it could be problematic. Okay. Any other questions? Thank you. Appreciate your time. Hopefully it was a little more exciting.